instruction to do that. At least I think you will. And we're going to use our x-intercepts. So we are going to turn the page. Okay? Okay, Henry? iPads down. I don't want to see any iPads out. That's you. You don't have to do it right now. You'll find out after I'm done teaching, which won't take that long if we get going. Okay, you guys. Can you figure out where the axis of symmetry is on this? Can you find a way to describe this? This is the axis of symmetry, except I don't think it's quite in the right place. Does that look better? Why do you say it's off?
Because it's off.
Why?
It's not correct in the middle.
Okay, in the middle. That's what I'm looking for.
No, it's still off. I mean,
don't forget, you can't look at the axes. You have to look at just the blue.
It actually is.
So let's find out. I'm going to trace this as best I can. Actually, I didn't even want the whole thing, but that's okay. And then I should be able to flip that left, right. And it's still in the same place. It's exactly halfway in the middle. Okay. So how do you find a number that is in the middle? Like if I have the numbers, let's see, 0 to 4. What number is in the middle?
2.
Why?
Because it is. It's between 0
Okay. No, we're not doing that right now.
Wait, wouldn't it be 2.5?
Nope, it's exactly in the middle. What if I did this? 0 to 5.
3. That would be 2.
What's halfway there?
2.5.
2.5. Do you guys know how to figure out what halfway is?
Yeah.
Okay, Joe and Jake. We're waiting for you, Joe. Put your feet down. You want to take some notes here. Well, we're going to use some what they call subscripted variables. We've used them already. This is x1. This is x2. And how do you find something that's exactly in the middle? What's an easy way to do it? Henry, do you know?
I don't.
You know how to do this. Okay, Susan. How do you find something that's halfway in the middle? How do you get 2.5? You divide it in half, right? So here's what you do. You add the values, okay, and you divide by 2. That's called an average. Remember, you've done averages. Do you remember averages? What's averages? Adding everything up and dividing by something. We're not doing that right now.
Okay, I'll put it on.
Thank you. Okay. So let's turn the page. Now, I want to find the axis of symmetry here. So I'm going to draw a little picture. Oh, actually, I want to get a Cartesian plane. Whoops. I always do that. Yes, I do. Yes. There we go. So why don't you draw a little sketch of where you think that would be, where the parabola would be using the intercepts. Okay, we're not doing that. We're doing math. You want to come up and do it? Plot the points? Come on up. So draw a little graph. It doesn't have to be fancy, because I can't do it without seeing the picture. Jake, I need you to be quiet.
We're wearing a pipe system. I mean, a pie, like,
And I have a pie necklace. Okay, Ray. It may be a little off. Do you want to fix it? Okay, -4 and Ray? 8. I know. Okay, David, where's the axis of symmetry? You guys?
right in the middle.
Where's the middle? Do you know how to do that?
Yeah, you go down 3.
No, you got to find where the middle is. What do you do with these two numbers?
Oh,
You add them and divide by 2.
4.
Okay, -4
-4.
plus 8 divided by 2. Nope, divided by 2. Okay, Cole, help him out. What's -4 plus 8?
-4 plus 8 is +4.
Henry, I need you to be quiet.
Divided by 2 is 2. 2.
Okay, so now you're going to graph the axis of symmetry. We're not going to get the vertex. No.
Are we supposed to graph this?
Yeah, I think it's good to sketch it.
How can you graph
That's okay.
something that doesn't have a graph?
You make the graph.
Easy. Okay, so where's the axis of symmetry?
Right there.
2. What kind of line is it?
That is a straight line.
They're all straights. What kind of line is it if it goes up and down like this?
That is
Axis of symmetry.
Vertical. So draw a vertical line. You can go up here and pick out a line if you want. So you got, I usually like the dotted ones. That's my preference.
The other way, horizontal.
This is horizontal.
I know that. That's the other way.
Okay, so I'm collecting your packet today, so you need to do it.
Wait.
Okay, now that's okay. Oh no, okay, just draw it. There you go. And then you can move it. Oh, perfect.
Oh, wow.
Now, what is the equation of that line?
2.
No, what's true about the x values?
2.
So x is always 2. That's the equation of the line. And so the parabola's vertex will be on this line someplace. I don't know where, but we'll find that out later. They could be fat parabolas, yes. My only thing is I want to find the axis of symmetry. That's my only goal today. Okay, let's try. Are we ready to turn the page? Suzanne.
What are we supposed to copy down?
Supposed to write exactly what's up there.
Basically, you have exactly what's up here. Because you just draw a little graph like this, and you estimate -4 and 8, and then you estimate your axis of symmetry, and you say x equals 2. I won't use a graph. I'll do it freehand.
Is this what we're going to be working on now?
Yeah. Then we're going to learn about where the vertex is, all the intercepts, and connecting the equations with those things. This is part of quadratic algebra. So if you know how to do the next thing, go ahead and do it. While we're waiting for people to get caught up.
I just punched someone.
Oh, guess what? You get some graphs here.
Yay!
Don't know why there wasn't one there. Okay, Lindsay, you got yours all done? So turn the page. Who said wait? Okay, ready? Shh. Ready? Okay, where are the intercepts, Henry?
7.
Julian, do you know where the intercepts are? We just did a quiz on this yesterday. So x plus 7 equals what? Now, you guys, some of you don't want to write this down, and the problem is you're getting it wrong. X plus 7 equals 0. So solve for
You
x.
can say my name because I already did this.
No.
Oh, I was like,
Okay, well, x equals what?
-7.
Minus 7.
you know, technically with these ones, with the x plus 7 and x plus 1, you could really just like write -7 and +1 because that's the answer.
But the problem is when I see this, 2x plus 1.
Well, yeah, but that's different. But like when it's
Well, it isn't different, but it's not as obvious.
well,
So the problem is because we don't write this here, we don't know what to do with that. That's the problem.
okay, well that's like a different.
Okay, Cole. No, you don't, because I've already answered questions today about it. Okay, so I'm going to graph -7, 0. 1, 2, 3, 4, 5, 6, 7. Is that right, Joe?
Yeah.
And then 1, 0. I want to know where halfway is. You could count. It's what? -4? 1, 2, 3, 4. Is that halfway? Julian, how'd you get that? Did you just count? What if I can't count? What if it's not a problem that you can count on?
Count? Well, then you need first grade.
So it's -7 plus 1. What did you say? It's negative what?
What does that say?
Average. Julian, what did you say? -3 or -4?
Right.
Is that halfway?
Yeah, it is.
That's what I'm saying. Sometimes we don't count. Because I touched my finger. So all you do is average it. You add these two values up and divide by 2. What's a -7 plus 1?
-8.
No, it isn't.
Oh,
-6 divided by 2 is -3. What's the equation for this line then? X equals what?
-3.
The axis of symmetry is always going to be x equals. Joe, Lucas, question? Turn the page. All you do is average them. Now, these are nice numbers to count with, but what if I didn't have nice numbers? What if I had x minus pi and x minus 2? No, I got to find the place halfway between them, so I'll take pi plus 2 and divide by 2. Pi is a number. What number is it? Oh, he knows more than I do. I know this far.
Oh my gosh, you should be teaching.
Yeah.
Can I get my teaching license? That's all you need to do.
What do you need? I thought you would ask me something. Okay, so it's not hard until you get to a problem like this.
But that's not that hard.
Oh, I'm sorry. Well, it is if you don't know how to factor.
Well, we've been working on it. They should know.
We should know. I know. Okay, Lindsay, question?
Why do they use pi?
Where did pi come from? It's the ratio of the circumference of a circle to the diameter. So if you were to take a circle, measure the length around, and measure the diameter, that ratio is always 3.1415. Did you guys know that you can draw an irrational number? Do you know what an irrational number is? Square root of 2 is an irrational number. Suzanne? Yeah, what is it? Suzanne? How do you draw that? You guys know, but that? No, you can't. You know what? This is 1.414, and it goes on forever in decimals, but I can actually draw it exactly, a line exactly equal to the square root of 2. No. This length is 1. Do you guys know Pythagorean theorem?
Yeah.
Do you remember in a right triangle, if you square the legs and you add them up, that gives you the hypotenuse? What's 1 squared? Cole? Now, what's 1 squared? Well, you don't know what 1 times 1 is?
1.
Plus 1 squared is 1 equals h squared. So 2 is equal to h squared. How would I undo the squaring?
Divide by 2.
No,
No, the
What's the opposite of squaring a number?
square root.
Square rooting a number. And we'll be getting into square roots. Joe, put your feet on the floor, please. So we're going to square root both sides, and so h is equal to the square root of 2. So if I actually measure a segment of length 1, and this segment's length 1, this is exactly equal to the square root of 2. And that's how you draw an irrational number. You don't have to take notes on that. That's just a point of interest. Okay. Okay, let's do that one. Joe, how do I do that one? Cole, how do I do that one?
You have to
Put x on x.
I want to know where this is what? 0. Because y is not always 0, so I can't put equals 0 up there.
2 plus 2.
I need to do parentheses, Joe.
4 2.
So,
X is on both sides.
Plus 2 and minus 4. No, minus 4 and plus 2. Plus 2 negative 4.
how do you know?
Because
You check it. You multiply it out. Okay, David? Did he do it right?
Yeah.
It is right. So what are the intercepts then?
plus 4.
4 and what?
Minus 2.
Good. So if I were to graph that, 1, 2, 3, 4, 1, 2, and then I'm going to be halfway in between. Now let's not count, Julian. Let's just average them. What do you do with them? You add 4 plus a negative 2 and divide by what?
2.
2. What's 4 plus a negative 2?
2.
2 over 2 is
1.
1. So there it is. There's my axis of symmetry. My parabola does something like that. And we can model many things with the parabolas. Joe, I need you to sit in the back over there. Permanent. Okay? Joe, get going. Okay, anybody want to come up and try this?
I do. I think.
Do you? Yes, Henry.
I'll go with G.
There you go. What? I said yes. I said yes.
Oh, she said yes?
Yeah.
He said no. So I can go to He said yes.
Yes, go. God.
equals 0.
Wait, where's he going?
Potty.
Oh.
Okay, you guys, it's not going to be right if you don't put equals 0 in there because it's not how you do it. Okay, so he says negative 9, negative 3. Where's the axis of symmetry? Where's halfway between negative 9 and negative 3? See, the problem is, what if they're not nice numbers? You're not going to be able to guess it.
Why do we need to guess when we can figure it out?
But what if it's 2.875 and a negative 5.976? How are you going to figure that out?
Well, that's not going to happen. Because you have
In the real world, we never have nice numbers. You have nice numbers in science class?
we're never going to use math in the real world.
No, you don't. Oh, parabolas are all the time in the real world.
No, I never see parabolas.
They actually build buildings on them. They also have all those suspension bridges. Those are catenaries, which look like parabolas. But what's the problem here?
Build chicken casseroles.
It's negative 6 because this is a negative 12
Negative 6.
over 2.
Wow.
Okay. Okay, what's the equation for it, though? Negative 6 equals what?
Negative 6 equals 6.
What variable is it? It's x. I think that's it. So you have a little worksheet to work on.
Here you go, take this.
You should be able to get it done, I think, within the class.
Hello.
What?
Hello.
And you will turn those in to me.